Column production started in epoxy granite and carbon fiber. Became a long story beyond imagination. I've finally made it this far. This is another operation I absolutely can't afford to mess up. I've spent so much time fine-tuning everything, so it has to go well.
What's up, freak? What are you working on this time?
Hey, Angel. I can tell you're dying to know more about this project. I totally get that. People all over the world are curious about it too.
It's not like I'm that curious. But freak's so fired up, I just have a feeling something hilarious is about to happen. He's totally going to mess up in some ridiculous, over-the-top way and make us all laugh.
Sorry, Angel. I'm afraid I won't be living up to your expectations this time. I'm taking things more carefully than ever, so failure just isn't an option. I've got the entire process mapped out perfectly in my head.
Whatever. So what are you doing this time?
This time, I'm finishing the biggest part of the whole machine, the column. I'm building a mold using carbon fiber plates and pouring epoxy granite into it. Once that's done, the structure up to the third axis will be complete.
So that means you'll be able to run machining tests too, right?
Exactly. So first, let me briefly go over the previous video before diving into today's topic. In the last video, I talked about how the column would be made from epoxy granite, and how it's important to precisely align the A and X axes before the left and right aluminum frames are cast together into one solid unit with epoxy granite. If that alignment isn't done at that stage, there's very little room for adjustment once the column is complete, and that could seriously affect the final machining accuracy. For more details, please check out the previous video.
You had a few slip-ups in the last video, but it all came together in the end.
In this video, I'll be building a mold using carbon fiber plates and pouring epoxy granite into it to complete the column.
Why did you decide to use carbon fiber plates for the mold in the first place? Normally, people just use wooden boards or metal plates to make the mold, then remove it after the epoxy granite has cured, right? Or they weld together square tipping to quickly create the needed shape and pour the epoxy granite into that. So why go with carbon fiber?
Good question, Angel. You probably already know that epoxy granite is a great substitute for cast iron when it comes to large structural parts like machine beds. By bonding gravel with epoxy resin, about 90% of the material ends up being just the aggregate. The finished epoxy granite ends up with properties very similar to natural stone. But unlike cast iron, stone is so hard that it can crack under stress. To compensate for that weakness, it's common to reinforce epoxy granite with metal inserts or rebar to improve its tensile strength. Another method is to pour epoxy granite into hollow metal structures like square tubing, which helps prevent cracking. That approach is very practical in terms of workability, but the problem is that standard metal tubing comes in fixed sizes, which limits your design freedom. If I had a better equipped workshop where I could easily cut and weld large metal parts, that would have been a good option. But I don't have that kind of setup. So instead, I decided to use carbon fiber chips and carbon fiber plates. Carbon fiber plates are harder and lighter than steel, often used in aerospace and racing applications, and they look great too. Even though they're extremely hard, they can still be machined relatively easily with diamond tools. So I chose to hand build the mold from carbon fiber plates and reinforce the joints using epoxy mixed with carbon fiber chips to make a mold that's nearly as strong as metal. And let's be honest, it just looks cool.
Oh, I see. So basically, you did it because it looks cool. I totally get that. I'm really picky about appearances too. You know what they say. If you want to fool a guy, start with the visuals. If a cute little angel shows up and asks nicely, guys will buy anything.
What are you even talking about? Were you even listening to what I said? Whatever. Anyway, the point is this. I actually have some experience building machine structures out of epoxy granite. The first thing I built was a base for my lathe using epoxy granite. After that, I made the saddle for this machine using epoxy granite. carbon fiber plates, and aluminum plates. This time, I'm going to build the column using the same approach, but its shape is much more complex than the saddle.
Oh, I definitely remember when you built the saddle. You gave us one of the most legendary fails I've ever seen. I honestly admire you for that. You're a true legend.
Let's just forget about that, shall we? Anyway, an experienced and brilliant engineer like me knows how to learn a lot from small failures. This time, I've come up with a perfect plan based on everything I've learned so far. Even though the column shape is complex, building it out of carbon fiber plates isn't all that difficult. What really matters is the pouring sequence for the epoxy granite. The mold needs to be completely filled with epoxy granite, but because of the structure, one side ends up not being fully connected. On the other side, it is connected, but there's a plate in the middle. Which could block the flow. So I decided to split the process into 2 stages. First, I'll pour and cure the upper half. Then I'll flip the machine over and pour the second half from the underside.
Got it. So you're basically doing the same process twice. Once for the top, and once for the bottom.
Exactly. I'll explain the details as I work. So, let's get started. First, I'll check the dimensions based on the 3D model and start cutting the carbon fiber plates. I'm tracing the shape based on the dimensions from the 3D model. Since carbon fiber is black, a white marker works really well for this.
Hey freak, by the way, that mouse you're using is super cute. What is it? Where'd you get it?
Oh, this mouse. Yeah, it's a pretty unique one. It's called the ProPoint, made by a company called Swiftpoint. What makes it special is that you hold it like a pen, so it puts way less strain on your wrist and arm. It also has gesture controls and built-in presentation features, so it's more like a tool than just a mouse. Once you get used to it, it's really hard to go back to a regular one.
That mouse is so cute. Hey, did you know? I just found out YouTube has this new feature where you can embed product links directly into your videos. And if someone buys through the link, a percentage goes to the channel as revenue. We should totally add a link for this mouse and cash in big time.
Is that true? There's really a deal that good. I mean, most of our viewers are probably tool lovers. They'd definitely be interested in a mouse like this. Now, I'm absolutely not someone who cares about making money, but for the happiness and peace of people around the world, I'll go ahead and add the link to this mouse. Please, if you're going to buy it, use the link. I'm begging you.
Pretty please, my lovely gentleman. Buy like 30 of them, okay?
Alright, next I'm going to cut the plates. For this, I'll be using a saw that's specifically designed for cutting carbon fiber. The corners can't be cut with a saw, so I'm using a rotary tool with a diamond bit to carve out enough space for the blade to get in.
Diamond bits are amazing, aren't they? Hey freak, I found the cutest little diamond ring the other day. I just know it would look perfect on me.
Buy it yourself.
Lately, watching someone cut carbon fiber with a diamond bit kind of makes my heart race. It's just so cool. Hey, freak, how about a date sometime? There's this jewelry shop I've been dying to check out.
No, buy it yourself.
Hey freak, it doesn't have to be a diamond, you know. I'd be happy with a gold or platinum ring.
Gold's too soft to cut carbon fiber. Give it up and be quiet.
Hey freak, why do you use water when cutting carbon fiber with a saw or a diamond bit?
Now that's a good question. It's been a while. When you cut carbon fiber, it produces extremely fine dust. This dust is similar to fiberglass, and if you inhale it, it can be harmful to your lungs. So using water helps keep the dust down while you're cutting. It also cools the blade or bit and helps extend its life. Pretty efficient, right?
Alright, that makes sense. But just so you know, I'm still not over the jewelry thing.
Anyway, I've managed to cut out most of the main parts. All the chit-chat slowed things down a bit. Now I'll start assembling the mold using these carbon fiber plates.
You know, I've always wanted to look at cute rings in a shop like that. But going alone to a place like that, it just doesn't feel right. That's why I want to go with you, freak. Of course, I'm not saying you have to buy me anything. I just want to go shopping with you.
Stop making weird AI-generated videos, Angel. Get a job and buy it yourself.
If you're gonna talk to me like that, you'd better raise my appearance fee and cover my travel expenses too.
Oops. All this pointless chatter is making it hard to focus. If I mess something up because of you, Angel, that'd be a disaster. Time to get back on track and focus. I'm leaving a slightly larger gap between the plates and filling it with carbon fiber chips mixed with epoxy. In my experience, having a bigger gap actually works better. It's been a day. Now I'm going to remove the tape I used for temporary holding.
This actually turned out pretty well. The surface is smooth, and you can really see the pattern of the carbon fiber chips.
Told you. I've tried a lot of different methods and built up experience over time. Everything's been carefully calculated. I decided to assemble the parts step by step like this. Trying to build everything at once tends to lead to warping.
So far, so good. So far. Are you seriously casting the masking tape into the mold too? Why?
Well, after considering various possibilities and using a bit of imagination, I thought maybe it could have a positive effect. Somehow.
Just admit it was a mistake.
The 9mm aluminum frame for the C-axis also functions as a reinforcement plate for the column, and it's bolted in place. The reason I'm using bolts is to make the entire C-axis removable for maintenance purposes. When drilling into carbon fiber plates, I widen the hole step by step, since the router doesn't have a lot of power.
Hey, what's that hole for?
You see how the saddle sits on top of the column, right? The spindle unit is mounted on the saddle, and it adds a lot of weight. The plan is to use a cable to pull against that weight and keep the whole thing balanced.
So basically, like a counterweight.
I'm not using an actual weight, but yeah, same idea.
Ha, you've actually thought this through. Hope it works like you planned.
You'll find out soon enough. Just wait and see.
What are you doing here? That's a lot of bolts.
I'm using them to bond the aluminum angle to the epoxy granite as one solid unit. Without them, the aluminum could peel off over time.
What are you doing here?
These shaft holders shouldn't be fixed directly into the epoxy granite. They need to remain independent so the A-axis center line can still be adjusted.
So after the column is complete, the final adjustment will be done by fine-tuning the position of these shaft holders.
Exactly.
I'm not really sure what you're doing here either. Can you explain what this part is?
Yeah, I guess it's hard to tell without an explanation. Like I said earlier, I'm building the column in two parts, top and bottom. This right here is the dividing line. So I'm making sure the epoxy granite stops exactly at this point when I pour it.
I see. That makes sense now. What's this? Why is it all sticky?
What the? What's going on here? Did the epoxy not cure properly? Why is this happening?
You were probably drunk again while mixing it. I bet you messed up the hardener ratio.
I don't think so. Probably.
I'll do a quick search online. According to what I'm seeing, there are a few reasons why epoxy might not cure properly. For example, using a wrong ratio of hardener, not mixing it thoroughly, or working in the wrong temperature or humidity can all cause issues. Looking at the current conditions, temperature doesn't seem to be the issue, and I doubt you undermixed the epoxy. So the only real explanation is that you were drunk and messed up the mixing ratio. That must be it.
Why is it that the moment you suspect I might have made a mistake, you suddenly get all excited and start giving a perfectly logical analysis? Do you have some kind of grudge against me?
Obviously, because you still won't buy me the jewelry I want. Forget going to a store together. Just go online and order 5 or 6 pieces right now.
Wait, what? How does messing up the epoxy ratio mean I owe you jewelry? And what does 5 or 6 even mean?
Science. Underestimate the power of an angel, and you'll regret it for the rest of your life.
That's basically a threat. At least, limited to 1.
Fine. I'll graciously settle for 1.
Just make sure it's on the Black Friday sale list when you pick it.
No.
Anyway, let's reset and move on. What's done is done. From now on, I'll be extra careful with the epoxy mix. Especially when working with small amounts, I'll start using a dropper to measure the ratio accurately. The mold is complete. Now I'm going to mask off the surrounding areas to make sure the epoxy granite doesn't get where it shouldn't. Now that everything is ready for pouring the epoxy granite, I'm going to decide on the ratio of gravel to sand. This is something I struggle with every time, but this time, I'm trying a new approach. I'll start with the largest gravel as a base, then fill the gaps with the second largest gravel, and finally use either smaller gravel or sand to fill the remaining voids. I figured this might give me the most efficient and balanced mix. I don't know if it'll work, but I'm going to try it anyway. Something like this should work. After actually trying it out, it seems like the different densities of the gravel and sand had more of an effect than I expected. It didn't go exactly as planned, but overall, I think it turned out pretty well. To avoid messing up the epoxy ratio this time, I marked the correct levels on the cup. This time, I'm adding carbon fiber chips into the epoxy granite to improve its tensile strength.
You know, that kind of looks tasty. I'm starting to think it might actually be edible.
You're right, it does look pretty good. Maybe I'll give it a little taste. It's nice and crunchy, not bad at all. Now if I had a beer, this would be perfect.
Turns out your brain isn't the only thing that's broken.
Alright, it's time to pour the epoxy granite. I've done all the prep work up to this point. It has to go perfectly.
I've got high expectations.
The epoxy granite feels stickier than I expected. I wonder why that is. As I thought, the flowability is too low. The epoxy granite isn't spreading properly. At this rate, it's going to be full of gaps and end up low quality. I have to improve the flowability somehow. I'll add more epoxy.
Hey, freak, the camera angle's not great. I can't see the spots where the epoxy isn't flowing properly.
I don't have time for that right now. I need to fix this before it starts curing.
Wait, are you seriously using a ruler to spread the epoxy?
I didn't have the right tool. Okay, ruler, whatever. It doesn't matter, as long as I get the epoxy into every gap. I've figured out why the flow is so bad. It's because I added too much carbon fiber. That raised the viscosity and made it harder to spread. This is not good.
This is not good. I can finally see the spots where the epoxy granite isn't flowing. Wow, it's really not moving at all.
I can fix this. I've solved so many problems before. This won't be any different. It's going to be fine. Because I'm freak. I'm freak. I am freak.
You are the freak.
This is just a cut-up power extension cord. It's got just the right balance of stiffness and flexibility. Feels pretty good. I think it might work well for pushing out trapped air from the epoxy granite. The result wasn't exactly what I expected, but in the end, I think it turned out pretty well. Next time, I'll skip the carbon fiber. Once the epoxy has partially cured, I'll start peeling off some of the tape and cleaning up any overflow. If I wait until it's fully hardened, it becomes much harder to remove. Before the epoxy fully cures, I'm going to check the alignment between the A-axis and the X-axis. Since I did quite a bit of hammering, there's a chance things have shifted. Right now, I can still make adjustments if needed. Perfect. My work is always perfect.
What?
For now, the upper half of the column is complete. I was planning to show the lower section in this video as well, but it was getting a bit too long, so we'll cover that in the next one. The work itself is already done. I just need to edit the footage. It shouldn't take too long. Hope you all enjoyed this episode. If you are interested in this project, I suggest you subscribe to my channel so you don't miss any videos. If you empathize with my project, why don't you become a member and support this channel? There are a few benefits, but as long as you are a member, your name will appear at the end of the videos as a patron. In other words, you can be a part of this project. So, please look forward to the next video.